In this video today, we are going to see a physics problem based on a water balloon. Let's first try to understand the problem statement. We have been given that a water balloon is thrown horizontally with a speed of 8.31 meter per second from a roof of height 23 meter, as shown in the figure. Just imagine this situation that you are standing on the roof of a building, which is having a height of 23 meters, and you are throwing the ball horizontally at a speed of 8.31 meter per second. The problem says that we have to find the horizontal distance that the water balloon will cover when it strikes the ground. We have to assume the origin of the coordinate system is at the top of the building, which I have highlighted over here, with right and up as a positive directions. And we have to also assume air resistance is negligible. Now, what happens is when you throw the ball horizontally, there might be some air resistance acting on the water balloon, which may try to lower the horizontal distance that it can cover in the absence of air resistance. So that's why we have been asked that we have to assume that the air resistance is negligible in this case. So what we'll do is we'll first write down the given data. The horizontal velocity Vx is 8.31 meter per second. Now this is the velocity with which the ball is thrown horizontally. We have been also given the height of the building is 23 meter. Now just imagine that you're standing at the roof of the building. So your initial position, since your position is assumed as the origin of the coordinate system, so the initial y position, let me denote that by yo. So that will be 0 meters. Then the final position of the water balloon, that will be minus 23 meter. So this is the position of the water balloon when it strikes the ground. Okay, so since any distance below the origin will be negative, that's why the final position y is taken as minus 23 meters. Now the acceleration due to gravity ay is minus 9.81 meter per second square. Now, under normal circumstances, we usually take the acceleration due to gravity as 9.81 meter per second square. But please note that this is a problem of freely falling object, and the object, which is the water balloon in this case, is falling downward. That's why we take the acceleration due to gravity as minus 9.81 meter per second square, where the 9.81 is the magnitude and the negative sign, it indicates the direction of the water balloon, which is downward. I can also write the initial velocity in the y direction is 0 meter per second. Now this velocity refers to the y component over here, the initial velocity and its y component, that is 0, because the x component is 8.31 meter per second, but there is no y component since the water balloon is thrown horizontally. So that's why Vyo is 0 meter per second. Now I will write the system of equation, basically the equation of motion for the y direction. So y, which is the final position of the object, is equal to the initial position of the object yo plus the initial velocity into time plus the acceleration due to gravity into t square. Now this is the equation of motion in the y direction for a freely falling object. Now I will just enter the data that is given to us and which I have also written over here. So that will be minus 23 is equal to yo is 0 because that is at the origin. So that I will put as 0 plus we know that the initial velocity is 0, which is the y component, 0 into t plus 1 by 2 into AY, we know that is minus 9.81, so I'll just put that as minus 9.81 into t square. Now I can rearrange this equation and I can write t as under root of 2 into 23 over 9.81. Now further simplification, t you can find as 2.2 seconds. Now physically what this means is when you throw a water balloon at a horizontal speed of 8.31 meter per second from a building of height 23 meters, then it will take about 2.2 seconds for the water balloon to reach the ground surface. Now, when it reaches the ground surface, what will be the distance, the horizontal distance of the water balloon from the building? So that can be easily calculated as delta x will be equal to the horizontal velocity with which we threw the ball into the time it takes for the ball to reach the ground surface. So that is 8.31. So we have been given this velocity 8.31. Or to be more specific, we can also write this as Vx0. So that will be 8.31 into 2.2. So that is 18.3 meter. So this is my final answer. So it will take about 2.2 seconds for the water balloon to reach the ground surface. And when it does, it will be at a distance of 18.3 meter from the building. I hope you were able to understand all the steps. And if you have any questions, you can write me in the comment section. Thank you.